Hello guys, so in this video we are going to discuss about pipeline and machine learning with the help of Sklearn and Python. Now, till now we have solved so many different kind of machine learning problem statements. We have seen what are the different models we really need to solve. Like feature engineering, and in feature engineering it can be handling missing values, doing some kind of column transformation. Probably trying to apply dimensionality reduction techniques like PC and all, and then finally applying a model and then deploying a model. Now, this particular process you can obviously do in Jupyter Notebook also line by line. But when we go ahead in implementing an end-to-end solution, right, the initial EDA analysis can definitely be done with the help of Jupyter Notebook. But when we actually convert this into a modular coding, it is better that we start using pipelines. Now, pipelines sequentially apply a list of transforms and a final estimator. Final estimator basically means any kind of machine learning algorithms. So in this video, I'm going to cover about pipelines. I'm going to do a detailed explanation about it, how we can basically implement, how we can apply different transformation techniques with the help of pipeline. And we'll also see that how we can apply clustering algorithms, how we can apply any classification or regression algorithms also. Please make sure that you watch this video till the end, because this will actually help you to understand in the later stages how to implement an end-to-end complete machine learning problem statement. Okay, so let me go over here and let me start discussing about pipelines. Now, first of all, as I said, over here from the definition, you can see that it sequentially apply a list of transformer and a final estimator. So list of transformers can be anything. Like we can basically apply feature scaling technique. We can basically apply a imputing technique. We can basically apply a dimensionality reduction technique. And at the end of the day, we will be applying a machine learning algorithm. Okay. So let's start with the basic thing. How do we go ahead with applying this pipeline technique? So first of all, I am going to import from sklearn.pipeline, import pipeline, right? So I will just go ahead and import this. And let's say I want to apply one simple technique of feature scaling. Let's say for feature scaling, the most common technique that we can definitely use is something called a standard scalar. Now, let's say if I really want to apply the feature scaling technique, obviously, you know that which library I'll be using. So let's say from Sklearn, I'm going to basically use something called as pre-processing. Okay. Pre-processing. Okay, I am missing the spelling. Okay, import standard scalar, right? So once I do this, right, and probably let's say that I want to apply a simple linear regression model. So for that, I will be using from a Sklearn.linear_model. I'm going to just import logistic regression or any kind of algorithm that you basically want. Let's say in this particular case, I will just use logistic regression. And this is my algorithm I'm specifically going to apply. Okay. Now, I want to combine this standard scalar, which is a transformation technique. Okay. Over here, I've just taken one. Later on, I'll show you multiple examples how we can combine many. Okay. So that is the reason I'm telling you, try to see this entire video. This is super important video and this will be super helpful when you're implementing end-to-end project. Okay. So here I'm going to combine this technique. One is transformation technique, and this is basically my estimator. Estimator basically means the kind of model that I really want to apply. So in order to apply this, first of all, I will just go ahead and create my steps. Okay. What all steps I really want to follow. And whenever we really want to create these steps, I have to basically give this in the form of like a key value pair, let's say in the tuple, right? So here, whenever I'm giving with the help of key value pairs inside a tuple, it becomes a name tuple. Okay. So the first step that I want to basically talk about is, this is my standard scalar. So this is the name that I'm actually giving. Okay. And this will basically get initialized to my standard scalar. Okay. So this is the first step that I'm going to apply after this. After this, I will go to my next step. In my next step, I'm just going to apply my logistic regression. Okay. Logistic regression, I can just give a simple name. Let's say I'll say this is as a classifier problem. Okay. And then I'm going to basically initialize this into logistic regression, right? Now this is perfect, right? So once I execute this, so this is my steps, a list of name tuples. And here you can see first one is standard scalar and second one is classifier. Okay. Now, if I really want to convert this into pipeline, all I have to do is that whatever pipeline I have actually imported, so I'll just write it down and I'll just going to give this steps. Okay. Steps. Now, if I press shift tab over here, you just need to give the steps. pipeline of transformers with a final estimator. Here we have a final estimator, we have a transformer, right? Transformer basically means I'm not saying that NLP transformer, but a list of transform which I'm actually trying to perform. Okay. Now, once I execute this, here you'll be able to see that this is how my pipeline looks like. So whatever data I'm actually going to give, it will go first to this particular step, and then it will go to this next step. Okay. When I do the fit, okay. And then automatically it gets trained. Let me just save this in over here inside my pipe variable. Now, the next thing that I'm actually going to do is that I'm trying to visualize this particular thing. Okay. And we have techniques to visualize this entire pipeline also in an efficient way. So for visualization technique, the technique that we are basically going to use is something called as set_config. So in order to visualize this pipeline, and this is also super important. Okay. Obviously, we can see from here, first we are applying standard scalar and then classifier. So here I'm just going to see visualize pipeline. Okay. And for visualizing the pipeline, what I'm actually going to do is that I'm going to import from Sklearn. I'm going to import set_config. Okay. So once I do this, and then if I just set it to something like set_config with display as diagram, I'll give you all these materials. You can definitely try it out, but I really want you all to see this video till the end, and please make sure that you hit like also. So once I do set_config with display as diagram, now if I probably try to display the pipe, okay, here you'll be able to see how easily this entire thing is basically, you can basically see that what all steps are involved, right? Here you have standard scalar, here you have logistic regression. This is also perfect. Okay. Now what I'm actually going to do, with respect to taking a simple data set, I'll just try to pass through this particular pipeline. Okay. And this will again be very, very super easy step. All I have to do is that take up any data set that you want. And for this, I'm just going to create my own data set. Okay. So for creating my data set, what I'm going to do, and you can apply this to any data set. Let's create a data set over here. Now creating this specific data set, I'll say from Sklearn dot datasets, I'm going to import something called as make classification. Since this is a classification problem, and you can basically create different kind of data sets like make moons, make multi-label classification, make regression, so that you don't have to be dependent much on the data set initially. Just to practice, I'll just go ahead and write make classification. Now inside this, what I'm actually going to perform is that I'll just initialize this with x, y, and I'm going to say, okay, I'm going to call make classification. Okay. And let me just initialize. By default, if you go and see this, okay, with respect to mix classification, it is going to create two features, right? Sorry, it is going to create number of features as 20, and this is number of samples as 100. Number of classes in that specific feature, right? This y value will be 2. Okay. So here you'll be able to see all these features and how many data points it is creating, 100 samples. If you want to change the number of samples, you can basically write it down. Okay. It is up to you. Let's say that I just want to use n_samples as 1000, so that you'll also be able to see some good examples over here. So if I probably go and write x.shape, here you'll be able to see 1000 columns, 1000 rows and 20 columns. Okay. Now the next step is that I will first of all do train test split. So I'll say from Sklearn dot pre-processing import train test split. Okay. So let's see. Sklearn train test split. I think it should definitely be in the, okay, it is not in processing, it is in model selection. So model selection import train test split. Okay. And obviously I will just go ahead and copy and paste this particular code. Let's be a little bit smart instead of writing each and every line of code. So I'm just going to copy this. Let me hide this. And here we go. Perfect. I'm just going to copy this and I'm going to paste it over here to create my X-train and Y-train data. Perfect. Now, after the train test split here, what I'm actually going to use, I'm going to use my pipeline and I'm going to do the fit on my X-train and Y-train data. Okay. So all I'll be doing pipe.fit on X_train comma y underscore train. But now here you can see that we have not done standard scaling separately. All the processes inside the pipeline. So once I do dot fit on x train and y train, it will basically going to pass through this particular pipeline, and finally you'll be able to see that it will get trained for this logistic regression. In short, when my entire data goes right in the standard scaler, it is going to take that train data. Internally, it is going to perform fit underscore transform, and then it is then going to train it with the help of logistic regression. So once I execute this, here it is see that my fit has actually happened. Okay, and probably if I really want to do the prediction now, dot predict, right, with my x underscore test, here you'll be able to see that my prediction will also happen. Okay. So now in the prediction, now you should understand in the prediction, this x underscore test, when it passes through this standard scalar pipeline, it is not going to perform fit underscore transform. It's just going to perform transform. And finally, you'll be able to see this entire predictions. Okay. So this is how easily you can basically use pipelines. Like you can combine transformation technique, feature scaling technique and all, and you can do this. Okay, so this was one of the examples that we specifically performed over here. Now let's go to some more complex examples and let's see that how we can combine multi pre-processing steps and classifiers and how we can do this. Now what I'm actually going to do over here is that I will first of all, again, use different techniques. Now, one technique is that I can apply standard scaling. I can apply dimensionality reduction technique, and then I can probably apply a classifier. Okay, so let's go ahead and let's do that. And let's try to see one more example. So this is my example second. Okay, example second. And in this example second, what I'm actually going to do, I'm going to display a pipeline with dimensionality. First of all, I will try to do with the standard scalar, then dimensionality reduction, and then estimator. Okay, just trying to make more complex things so that you'll be able to understand. Okay, so I'll make this as a markdown. Okay, so as usual, what all things I actually want, I will just try to import it. First of all, in order to use PCA, I'll say from Sklearn dot decomposition import PCA. Okay, so PCA has been imported. Then from Sklearn dot, let's say I want to apply another algorithm which is called as SVM, and here I'm just going to apply the SVC. Okay, so these are the two algorithms that I'm going to do it. Let's see what is the problem over here. Okay, some warnings. It's okay. We can actually handle this. It's not a big issue with respect to warnings. Standard scalar, I've already done that. Now let me go ahead and write all my steps. What all steps I'm going to follow. So this is my first one. Now in the first one, what I'm actually going to do here, obviously we need to do feature scaling. I just write scaling. For the scaling purpose, I'm just going to use my standard scalar again, which I have actually imported long back. And then the next one, the named tuple will basically be happening with PCA. Okay, and here I'm just going to basically write PCA. I'm going to initialize it to PCA, and number of components also I can basically give. Right now there are 20 components. Whenever we initialize with respect to this particular data, there are 20 features. I want to reduce it to, let's say, 2 features or 3 features. Let's say I want to reduce it to 3 features. Okay, so this is my second one. Okay, so the third step after applying the PCA, what I'm actually going to do, I'm going to apply my SVC model. Okay, since it is a classification problem. So here I'm just going to apply it to SVC. Okay, so these are my total steps, and all I have to do is that just go ahead and write pipeline and then probably convert this into this. And here is my entire pipeline. So this basically shows that in the first step, I'm going to apply the standard scalar, PCA, and then SVC. Okay, so I will just say pipe 2. Okay, so this will basically be my second pipeline. Okay, and now all I have to do is that just go ahead, pipe 2, and probably just write dot fit if you really want to directly use this with respect to any fitting method with respect to my extend data, so that it will pass one by one. But there are also some questions where which people say that, okay, Krish, I just want to apply, let's say that I just want to take up this scaling technique and probably see that how we can basically apply just standard scaling. That can also be your scenario, right? You don't want to apply all of the thing. let's say I just want to verify with one of them, and I can basically just check whether everything is working fine or not. So how do I do that? So all you have to do is that just write this particular name. That is the reason we are giving this name, right? So if I write pipe2.scaling dot transform or dot fit underscore transform, and that this step, let's say if I write fit uh, underscore transform, let's see whether this will work or not. And once I do the fit underscore transform, this I will do it in my Xtrain, let's say. So once I execute here, you can see that yes, it is working. So independently also, with the just a help of the key name, you can take it up and you can apply that specific function. Okay. But right now I don't want to apply this. I want to apply one by one all the steps, right? So all I'll do, I'll write pipe2 dot fit on my Xtrain comma ytrain data, right? So once I execute this, here it is perfect. Everything is there. And if I want to do the execution, pipe2 dot predict, and here I will just try to predict all my X-test data. So with respect to this also, you can basically do the prediction, right? So this was the second example, how I combined three over here, two feature engineering techniques, like one is standard scaling, one is reducing dimension, and then finally applying an estimator. Now, this is not it, guys. We are also going to apply grid search CV. So please make sure that you watch this video till the end. Now I'm going to display a more complex pipeline, and here I'm going to use something called as column transformer. Now see, there are techniques through which we can actually do feature transformation. Okay, so here let's take up a complex example of column transformer, and this is super important. Okay, and we'll try to see how we can basically do column transformer also. Right now I think these steps are used a lot, with respect to implementing anything. You will be able to use this. Now, first of all, what I'm actually going to do is that, let's say whenever we get a data set, the first step is that we basically try to handle the missing value. Now for handling the missing values, we in Sklearn, we have something called as from sklearn dot impute. I'm going to just import the simple imputer. Okay, this is specifically for numerical variables. For category variables, we can use some other techniques, but for numerical variables, we can use simple imputer. Okay, so let's go ahead and import this, and let's start creating the pipeline with different steps. Okay, so what we can also do is that we can create multiple pipeline and we can combine those pipeline together also, right? We can let's say that for processing numerical data, we can create a separate pipeline. For processing categorical data, we can create a separate pipeline, and then we can combine both of them so that it can be applied for the entire data set. Now this is super important, so please make sure that you watch this very closely. Okay, so let's say I'm just going to name it like numeric processor. Okay, numeric processor, and here I'm just going to create my pipeline. Okay, so this pipeline are there, and obviously inside this I'm just going to define all the steps that I'm going to use. So steps along with my name tuple. Okay, so here first is that I'm just going to see what kind of imputation I will try to do it. Let's say if I have a numerical variable, I want to just perform the imputation with replace the missing values with mean. So here I'll just initialize to simple imputer, and then this will basically be my missing values, which is treated as np.nan. So for this I'll also use numpy. Okay, import numpy as np. Okay, so wherever there is a np.nan, the type of strategy that I'm actually going to use for the imputing, I will say it as mean, right? Strategy. Okay, and again you can use different strategy here. I'm specifically going to apply it as mean. Okay, so perfect. Till here we have actually done it. You can see over here, this is my entire one step. Okay, and after this bracket I'll just open up another step. Okay, so another step here, I'm specifically going to apply standard scaling. Let's say scalar, and here I'm just going to apply my standard scalar. Okay, perfect. So here I've done this step. So this is basically my numerical processing pipeline. That basically means whenever I have my numerical variable, this is how my pipeline will look like. Okay, first of all, it has to pass through a simple imputer, then standard scalar and all. Now similarly, this is for numerical, right? We can also do it for categorical. So for numerical pipeline, processing pipeline, I'll just write it down. Processing pipeline. Okay, and then I will be doing it for categorical processing pipeline. Now for categorical, what all things we can basically use? Again, we'll use simple imputer only, but instead of replacing the missing values with something else, we can replace it with a constant. We can create a new category. Okay, so that is what we are going to use in the first section. So let me just copy this entire thing and paste it over here. Okay, I'll just change the name to categorical in processor. Imputation over here, instead of writing mean, I will say dot underscore constant. Okay, and then I'm going to apply the simple imputer. Instead of writing np.nan, I will just say that over here I will say fill. There is also another parameter which we can specify over here, and that is called as fill value. I'll say just say that, okay, wherever you find out the missing value, just replace it with a constant word. The constant word can be anything like missing. Okay, and obviously the strategy that should be used is a constant. Okay, over there we saw strategy that we used in numerical one was mean, right? Here we are specifically going to use constant. Okay, so this is the step that we are going to basically apply. And usually after applying this, right, we for categorical variables, what all things we can do, we can basically apply one hot encoding also. So for one hot encoding, I will just import another library. So for one hot encoding, what I'm actually going to do, I'm just going to say from sklearn dot pre-processing import one hot encoder. Okay, so one hot encoder is done. So here you can see that instead of writing scalar, now I'll just write one hot. Okay, so here will be my one hot encoder with the initialize technique, and wherever I find out any uh, unknown things, I'm just going to ignore them. Okay, perfect. So this is my categorical processor. This is my numerical processor. Now see, I will try to combine this. This will be quite amazing because now I'm getting my categorical processor. Now, if I really want to combine both this pipeline and then probably try to create this in a way wherein I want to combine this both now. Okay, but obviously I have to define my estimator also. First of all, let's go ahead and combine this. Now, in order to combine this, what we are going to do is that we are going to import another library which is called as from sklearn dot compose import column transformer. Now we are going to, I'm going to show you the importance of column transformer, because at the end of the day you are combining processors, combining processing techniques, right, in this, right? So from sklearn dot compose, you are just going to import the column transformer. Now in column transformer, one thing that you just have to do is that just initialize this column transformer. Once you initialize this, here you're just going to mention all the steps that you have, right, in the form of new numerical name tuples, right? So here first step is basically your, let's see what is the name over here, imputation mean. Okay, here you can basically give your own name. So categorical, this will be your categorical, and with respect to this, you're just going to initialize with respect to this category processor. Okay, so wherever, let's say if you have any feature in your data set, right, so you can just initialize whatever feature name is there. Let's say if there is gender, if there is age, right, or I'll not say gender, but here you can also have city, right? So this, what is this? This is basically your column names. Okay, gender and city, where you really want to apply the categorical processor. Now in category processor, what you have, first of all, you try to impute the constant value with some constant that is missing value, and then you apply the one hot encoding, right? Now once you do this, the next step, what happens is that in the next step again, after applying the categorical, you just need to apply the numerical. So numerical, here you can basically define, and this will basically get assigned to numerical processor. And in numerical processor, the third parameter in the column transformer that it can go is basically a column name. Let's say the column name is something like age or comma height, right? I really want to apply on this particular numerical processor. Okay, so here is what you're basically doing with the help of column transformer, and this will be my final not final underscore preprocessor. So I will just write it as preprocessor because still there are many things to develop. Okay, so once I do this, now if I probably go and see my preprocessor, here you'll be seeing an amazing diagram. Okay, so see this. Now this looks amazing, right? Your column transformer has two things. One is categorical and one is numerical, and it will go step by step. right? Here, simple imputer will get applied, then one hot encoder, then standard scalar, then simple imputer, right? So these steps, you'll be able to see that how quickly we have actually created this kind of pipelines. And when you are creating an end-to-end project, right? Like this only you have to actually go ahead and create, okay? Now, finally, still we really need to add an estimator. Now, in order to add an estimator, I will also be using one more thing from Sklearn.pipeline. I'm going to import make pipeline because we have to basically create a custom pipeline over here. Now in make pipeline, what I'm actually going to do is that I'm going to combine this entire thing along with that simple estimator. Okay, along with a simple estimator. So first thing first, I'm just going to apply all the pre-processing techniques, comma, I'll just apply logistic regression or whatever algorithm I want. And this is done. And this is my final pipe. Okay. This is my final pipe. Okay. And now if I probably go and see my pipe, this is how it looks like, so nicely. Column transformer, categorical, numerical, simple imputer, logistic. So once this gets over, it is going to go over here. And this is just going to do the transformation technique. Now, all you need is that you need a data set which has this columns like gender, city, age, and height. And probably you will be able to do this. Probably I can also create an Excel sheet over here, manually create all this particular data set, and then you can basically combine it. So in short, what I have actually done is that combined multiple processing techniques. For categorical, I can create a different pipeline. For numerical, I can create a different pipeline. Then I can combine this both with the help of column transformer. And then finally, I made a make pipeline where I'm combining it with an estimator. Estimator is nothing but it is basically logistic regression. So here is how it looks like. See this? Construct a pipeline for the given estimator. Okay. Now, in the next video, I will try to show you with respect to grid search CV also how we can do pipelining concept with grid search CV. So yes, I hope you have liked this particular video. Again, try it from your side, try different approaches, try to create this particular pipeline like this, try to apply in a data set, and then you will be able to get more and more perfection as you go ahead. And don't forget to use Google, because I also use Google a lot in order to see all this kind of examples. So in the first instance, you'll not be able to get it exactly right, but definitely see the combination that is possible. Okay. So yes, this was it from my side. I'll see you all in the next video. Thank you. Bye-bye. Take care.